My research focuses on how neurodegenerative diseases start in the brain. So we know that in neurons there are many proteins and other biomolecules, and these biomolecules sometimes can assemble into different structures. Some of these structures are extremely toxic to the cell, causing the death of the cell, and that leads to the development of the disease. The outcome of my research is to fundamentally shift the understanding of the molecular basis of how these proteins form into amyloid structures. So the trend in vitro, in test tube experiments, is that we tend to do it in perfect thermodynamic equilibrium. Nothing changes over a span of time. But in cells, it's extremely dynamic and everything changes constantly. So what we want to bring is this out of equilibrium nature into our test tube experiments to understand how this disease starts. So our hope is that this will have an impact in both fundamental scale and also translational scale. In fundamental aspects, we would have more understanding of the molecular origins of the disease and how they develop. And in the translational aspect, we would design new therapeutic intervention points which were previously overlooked, and also help to diagnose these diseases at an earlier stage. We would communicate our findings not only to the scientific audience via scientific articles and conference proceedings, we would also communicate to the general public, especially Parkinson's disease-affected individuals and their families. I'm also in direct collaboration with DTU Skylab, which will help me to translate my findings into a commercially available platform afterwards.